The first homework is to train a network to recognize small images, grayscale. It's 28 by 28 images. This data set is called the phasing MNIST. You know MNIST, right? A small data set prepared by Yang Lacan and used as a hello world for learning deep learnings, right? And because the data set is very easy to get high score, like 99% accuracy, so some researchers propose to use images. I mean, phasing clothes or other things to replace original MNIST. Let's see, this data set was created by Zalando. Supposed to be an online shopping website. So let's take a look at the phasing MNIST data set. So it's a MNIST-like data set which include 70,000 28 by 28 labeled phasing images. So here are the class in the data set. First is t-shirt, trouser, pullover, dress, coat, skin, sandal, shirt, sneaker, bag, and the ankle boot. So ladies may find this homework more interesting, a little bit more interesting. Okay. Data card. So you can see the details. And there are already many code that you can reference to. Data card is open data set. So here is how the data look like. Actually, it contains all the pixels, 28 times 28, 784. Yeah. In one file, in CSV file, usually we use binary file, but because this data set is small and each include the label. Label 1 is what? T-shirt. Yeah, T-shirt. And then there are multiple data set, test and train. Don't use the test data to train your model. Okay, it's considered cheat. But if you use it, I don't know. Sure. Okay, so the most important thing is that I need to identify your account. So please use an account that including your student ID, so I know it's you. Okay, register, join the competition using an ID that include your student ID. So, yep. And then there are already many examples. So let's take a look at examples. I have a notebook. Of course, you can find a better notebook than mine. So you can copy and edit a notebook. But I just copied. Okay. So the first step is to add the data. Of course, my homework has added the data already. You can search phasing MNIST. And click the add into the data set. Once you add the data set, you can see the input here. All right. Kaggle will copy the data set under your folder, under your directory. Okay. So, usually it will create a folder for you, because this is the old homework. In our new homework, it's supposed to be 112-1 NDUTE AI homework. This is my old example, but it doesn't matter. because the data set is in the phasing MNIST. That's it. The output will be put here. Okay, go working. So then we can run this data set. Another setting is that if you want to have more faster performance, you need to turn on your accelerator. You have a quota that you can use free accelerator, free GPU 30 hours per week. So it's free, right? So if you feel it's not enough, buy more computing resource. So then we can click the play to play notebook. You first download the dataset and then the first block of code is just to show the data under the input. Right, so it shows all the data on the phasing MNIST, which we can see here, all the same. And then we can read the data, input data from the phasing MNIST data, train and the test. We can use pandas to read data because it's from the CSV file. So we don't want to handle it by ourselves. So we use pandas. Pandas is for data processing. NumPy is for processing vectors array. Okay, then we use the train. Show the head, and then we can we need to do some process. We need to drop the label. We want to keep only the image data. That's the reason why usually the label and the data are separate. The image data and the image labels are usually separate file. But here we can drop the header. It's fine. Drop the label. Drop the first layer. Here's the label, right? Drop the first column. Then let's take a look how many data we have. 60,000, that's correct. Then we can show. Usually we want to take a peek of our data set to check if we have correctly processed the data. Right? It's a good practice to take a peek of your data set. So it looks like a browser. And then we can create a small neural network. Of course, because our class is about AI, maybe you can select other algorithms using NumPy. Usually, the other choice is SVN. Maybe I can try to give you an example, but today deep learning everywhere. We give them a select the training optimizer, training algorithms, and the loss function. And we can normalize the training data. Okay, we will talk more details in next class. Then we can start training on the data set. So it's very fast if you turn on the GPU, but remember to turn off it when you are not training data. So you can change the number of epochs. Epochs means the number of times you go through all the data. Bench size means how many data you want to use for each training. Usually our GPU memory is not enough for put all the data in one card or one memory. It's not large enough for put all data into the memory at all the same time. So that's why we need bench size and epochs. The result is 90. Not too bad, not bad, right? Accuracy is 90% accurate. So that's it. then you can make a prediction of test images and then save the results in the prediction file, and you can download it. So here is the answer. We can download the answer, but we don't know the. Suppose we didn't show the test accuracy here because suppose you don't have the test data for a formal competition. The test data are private data, right? But it's open source. It's the phase shift MNIST is open, so you can test on the test data. Check the accuracy by yourself. You have the labels of the test data. Okay, then let's see. So go back to the competition. Our data is downloaded from phase shift MNIST, so this data tape only show the prediction results. The prediction results include that the ID of the image and your prediction, which category belong. This image belong to. So that's it. And then here comes the most exciting part. We are going to submit the competition. Competition. You just download your CSV file and submit. Or you may see a submit button in your notebook because this is not the notebook for our competition. So yeah, just move it here. Yes, then you complete your homework. So there's the most simple ways to download the example prediction results and then submit directly. Then you will get 89. But I know all students are work very hard and want to learn and want to understand the machine learning and deep learning. So you will run the code and upload your own results. Okay. But if you are too busy, you can just download the CSV file and upload. Not recommended, but you can do it. So then you will have a